Hello, Andy is here. So, without much ado, I'll start to fade out this wonderful piece of music that he recommended. And we can just get started with the session. Over to you, Andy.
Thank you so much, Sid. It's lovely to be here. Thank you for your patience and for listening to the Earth Mantra with me and my friend Malte. Right, let's go. So, as some of you might know, and I assume most of everybody on the call does, the kernel syllabus is pretty focused on Ethereum. It does mention Bitcoin a number of times, particularly early on in the modules. And then it really spends a lot of time focused on Ethereum and EVM-like technologies, because that's where the majority of the attention is, and probably where a lot of the interesting development happened at the time when the syllabus was being written. It continues to be the case to a large extent, despite what you might hear on Twitter, although there are significant developments that take place in other ecosystems, and it's worth paying attention to what happens there, everywhere from Solana to Avalanche to various other side chains and layer ones. Move is an interesting one. Each one of these has contributions to make to the push towards truly decentralized systems that are robust and resilient, and which put more agency and responsibility into ordinary people's hands. I think probably one of the most exciting overviews of the recent developments in EVM adjacent technologies is given by Georgios in a podcast with Anna Rose and Taran Gupta recently. If anybody listens to the Zero Knowledge podcast with Anna, it's really great. I love it. I highly recommend it. They interviewed Georgios about Reth, which is Rust-based Ethereum, and the work that they're doing on execution extensions. And in that episode, he gives a really wonderful overview of the work that happened to get to a really interesting consensus protocol, which is basically Tendermint, and then like all sorts of versions of Tendermint that have happened since Cosmos launched, and they basically all have the same shape. And indeed, Ethereum's proof of stake is largely based on Tendermint. And then different contributions from Polkadot and now sort of actively validated services that you see appearing in Eigenlayer. All of these things, he makes the point that there was this Cambrian explosion of technologies, and we saw the decoupling or the modularization of a whole lot of different stuff to try and figure out like what works and what doesn't. And we're now kind of seeing a convergence again into using all of those new insights and ideas that have come about in each of these seemingly separate arenas, and applying the best of a previous understanding of technology from various Web2 services to try and get like highly performance, really efficient systems that nevertheless serve the original goals that everybody came together for here, which was censorship resistance and the ability to truly connect with other people, the ability to do so on your own terms, the ability to trust others, once again, to repersonalize things and deprofessionalize them, in the words of Ivan Illich, that kind of stuff. So all of that's wonderful, right? And I'm very excited about it all personally, and I think that that's great. There is another whole stream of stuff, though, outside of what I've been talking about, and that's what today's presentation is on. It's on Arweave. Now, we have had Sam from Arweave talk to us on numerous different occasions in kernel, so we happen to know quite a bit about who he is and what they are, and Vivek's most recent interview with him was really lovely. I highly recommend it. He was his usual silken self. And Arweave has kind of been going since 2017. They have done a lot of really interesting stuff. They've been operating largely on the periphery of most of these things, because the community around Arweave tends to be more aligned with Bitcoin than it does with Ethereum and a lot of the stuff that we've spent a lot of time looking at. Both sort of ideologically and philosophically, Arweave is somewhat closer to Bitcoin in terms of its goals and its narrative, and indeed the underlying technology. They used a sort of version of proof of work for a long time. Proof of access was basically proof of work with some tweaks to make it appropriate for storing data as opposed to passing messages. But they have happened upon a really interesting solution to how to go about building a world computer, which, if you remember the first Ethereum websites, was exactly the tagline, right? The world's computer. Ooh, very exciting. And it was certainly the thing that nerds like me. I was like, I want a world computer. That sounds wonderful. Let's do that. That's a great idea. And it's really fascinating that there is more than one way to do that. And this is actually what Georgios is talking about in that podcast that I began with mentioning, that everybody's been working on a world computer. Surprise. Sometimes it doesn't look like it because we all get kind of tribal about it and we're human. We have these petty conflicts and fights, but really everybody's been working on the same thing from different angles, different lenses, backdrops, priors, experiences, whatever you want to call them. And the route that Arweave has found to it is genuinely fascinating because it's not based on Byzantine fault tolerance, which is kind of the underlying premise of everything that we have done in Bitcoin, Ethereum, and EVM-like land, right? That whole trajectory of thought and technological development is all premised on this idea that, well, you really have to solve the Byzantine general's problem in order to have something interesting in terms of a distributed system that is capable of storing and agreeing upon the transition of large amounts of value. But Arweave is kind of like, well, like what happens if we're not generals in Byzantium? Like what then? What do we do? And that's really fascinating because the underlying network, the weave itself, has some really, really fascinating features that have then led to the implementation of a kind of hyperparallel computer, a world computer that is rather different to what we might be used to in the world of Ethereum and technologies like it. And that is because a lot of how Arweave works does not assume universal consensus. So I put out this tweet thread yesterday that I linked to in Slack because I wanted that to sort of be the presentation today. I'm kind of talking to it at the moment, but I like talking to you. So I hope that you have it around. I will just link it if you want it. Here it is. I think that might have been before, but this is the presentation that I'm talking to, and I want to just carry on talking about it. It will be linked in the YouTube recording of this as well, so you can follow along there if you're watching this at a later time. Hello, future people. We love you too, even if you're not with us in person. And the really fascinating point about Arweave that I want to make here is that there's no universal consensus, and that's really fascinating to think about, right? Because like everything depends on consensus and on being able to solve the Byzantine general's problem, have these Byzantine fault tolerance systems. And Arweave is like, yeah, like, maybe not, like what happens if instead we just let every node determine their own game? Like we'll write some open source software which specifies defaults for these nodes that you can choose to carry on adhering to if you so desire. And in this case, we rank each node based on the quality of access that they give us to the underlying data set in the weave. But anybody can adapt their nodes to rank other nodes however they want. Maybe I rank you higher if you send me payments in AR. Maybe I don't like AR, the token, and I want you. Send me that and I'll like give you a higher ranking, and that should like boost your karma in the network. Karma being an idea that originally kind of came out of BitTorrent and then adaptations of BitTorrent to try and find like a generalized way of doing ranking in decentralized networks that was resilient to people playing slightly different games, which is basically what was happening on BitTorrent, right? You had like the default clients that would rank other nodes by whether they were both sharing and taking data from the network. But then, a bunch of clever people were like, well, what happens if we adapted the rules and didn't just like give data to the network, but leached data, just took all data from the network and didn't contribute back? They called it BitTyrant. And yeah, like that kind of caused an upset on the network, and then they had to write new clients that were aware of that particular game style, the bit tyrant style, and were resilient to it. And they kind of speed ran evolution, which is quite a big claim, but that's essentially what happened, right? Like if you go and like look at one of the big questions in evolutionary history is how did cooperation first occur? Right? If it's a dog-eat-dog world and nature is really red in tooth and claw, how on earth does cooperation start? Because if you're like the first cooperating gene out there, being like, "Hey guys, I'm like, don't kill me. Let's like play instead." Like everybody, if they're like in a competitive mindset, they're just gonna kill you. So like your genes die out. Like how does cooperation start? And some really fancy mathematicians, Axelrod and Hamilton, actually proved that if you're playing a game called optimistic tit for tat, then cooperative behaviors are essentially gene driven through the population at enormously fast speeds. That is optimistic tit for tat, i.e. like I start by cooperating, but if you defect, then I'll defect in the next round, and if you cooperate, I'll carry on cooperating. So you kind of like start optimistically and then follow whatever the other player does. And that is a winning strategy. It's a dominant strategy in evolutionary history, and indeed in the history of a lot of these networks. It was in BitTorrent, and we took that and generalized it because they said, well, you can have karma for sharing data, but like potentially everything else if you want as well. And that is an absolutely critical notion, right? Because while they still have consensus algorithms about like who gets to add the next block with all of the data into the weave, they don't have universal consensus on how nodes are ranked in the network. And that's a really, really critical point to understand, because it speaks to the entire philosophy of the network, right? That actually trying to have one single global shared memory space, which is what Ethereum does, right? Like all of the contracts have their memory in one place, right? And that's why like the EVM is single threaded, and it's why state bloat is such a problem in Ethereum, because like everybody is writing to the same place, right? It's a place like all over the world. It's a no place, Nakuja Abad, but it's one thing. It's a monolithic thing, and it doesn't scale well, right? Like intuitively, it doesn't scale well. You don't have to have studied computer science to know this. It just intuitively does not scale to have like one thing that everybody's trying to use. And so you end up in all of these like strange and wonderful, like genuinely very interesting, but also kind of like, why are we spending so much energy on these problems? World where you have like MEV and priority gas auctions and all the stuff. It's all an outcome of the fact that we're all competing for yet another kind of scarce resource. In this case, it happens to be like digital block space. And while it's intangible and somewhat abstract, it's still, there's still scarcity of it, right? Because of the fundamental design of the system is to have like one shared global memory space and to enforce consensus on everybody at every step. Howie's like, nah, let's not do that. Let's do something else, which is that we can still maintain very strict rules around who gets to add data to the weave and in what manner they do so. And if you look at the history of the way that the network has evolved, it's changed a lot from kind of proof of access, a very naive implementation when they first launched in 2017, to proof of access with random X hashes, to succinct proofs of random access. That was like quite a recent one, which is really great. And these days now spores, which is like mushrooms. And it's succinct proofs of replication, which is a slight adaptation of succinct proofs of random access. And that is the manner in which they're able to ensure that the dominant game for nodes on the Arweave network is always to try and replicate the entire data set. How they do so is quite complicated. I don't want to get into on this call, but the dominant game is replicating the whole data set, right? Because that's the goal. They want to have like multiple copies of the whole weave, so that whenever anybody wants a particular piece of data, the guarantee that they can find it somewhere is very high. So they've done a lot of work to do that, but the point is that there's this almost brutalistic minimalism in terms of how they managed to get there with, without enforcing consensus strictly on all nodes, and without absolutely tightly specifying the game that you have to play or saying that it happens in one place. And that's relevant to the work that we're going to do today because AO is built on top of that and it's built using the same principles. Like it took people quite a while to figure out what the hell was going on with Weave and like how to build stuff on it because storage is kind of cool and like Filecoin and IPFS looks interesting, but like, I can like go and do this DeFi thing over here. It's probably going to be like much more flashy and like get me a Lambo much more quickly. But actually, like the storage game is, as I say, it leads to a very interesting route into this world computer, and it does so precisely because it thinks very differently about how to how to scale systems. And what I mean by that is if we take a look at the things that were built on Arweave kind of after its launch, it took them a long time to kind of like get bundles together and to really figure out how to set up the Merkle tree in the most efficient way and then bundle transactions together because you can only kind of, at the beginning you could like theoretically bundle as much data into a particular transaction as you wanted, but you could only do about 1,000 payments per block, and block time is about 2 minutes in Arweave. So that was a limit to how fast the network could move, and then they introduced bundles, and you can like bundle any number of transactions into a single transaction, so you have like 1,000 bundles per block, and you can do infinite number of payments basically per block. And again, that simple recursion is really important to what we'll talk about at the end of this call, which are subledgers in AO. And people then finally began building actually smart contracts and stuff on top of this. The example for that is Warp. Warp.cc is the link. And this is where people started being like, okay, well, now that we have verifiable storage and it's done so in a scalable way, which is quite different to IPFS. And that's the last kind of historical point that I want to make here, is that on networks like IPFS, as cool as it is, the problem arises in that every time you want to store a piece of data, you have to enter into a contract with a miner, right? It's a smart contract based network. The FVM, the Filecoin virtual machine, is what adjudicates these contracts in the same way that the EVM adjudicates contracts on Ethereum. And every time I want to enter into a contract, I have to go and deploy a new smart contract on the network and find a miner who's willing to fulfill the deal that I would like, the storage deal on the particular terms that I want, store it for this duration at this price in this way, right? And so every time new data is added to the network, a whole bunch of metadata has to be stored as well about that contract, about its terms, about the duration, about the price, blah, 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 right? And so that, again, the point that Sam and the Arweave team makes is that doesn't scale, right? Because every time that you're adding more data, you're adding more data about that data. And so there's just this kind of explosion in terms of what you need to store in order to have a functioning network. Whereas Arweave is again, forget all of that. Let's do the most simple and brutally and minimalistic thing that we can, because it's actually what leads to flexibility and scalability in the long term, which is just assume that all of the data stored here is permanent. And the way that we do that is we say, what is the cost to store that data over the next 200 years, looking at real world data about the cost of hard drives, essentially they look at the gigabyte hour cost, the price per gigabyte hour, and the amount of time between faults on a hard drive, basically. And both of those things are dropping at a massive rate. Moore's law applies very specifically to storage, even if it's slowing down in compute. The theoretical limit for storage is still hundreds and hundreds of years away. So we're still seeing that operate completely accurately. And then based on that real world data, we can take a very pessimistic estimate of it, such that we say it's probably even if it doesn't decrease, even if the cost for storage doesn't decrease at the rate that we expect over the next 200 years, we can price what it will cost to store this data for 200 years. And that's what you pay upfront once when you store the data. There's no extra contract, there's no metadata, there's nothing other than the data that gets put into the network, and the network defines this single upfront cost, which goes into an endowment. The thinking here is twofold. One, that in 200 years from now, 3 generations, we can at least guarantee that your data will last that long, right? And that in 200 years, there's the likelihood that a new technology will have emerged that does data storage in an even more efficient fashion is quite high. Just like there are numerous archives which are already rolled into Arweave itself, GopherNet, Telnet, the Library of Congress, a few others. And because of this endowment, which is, in AR, which is probably an appreciating token over time, we can most likely ensure that there will be strong incentives to go on storing this data for thousands of years past this, because the endowment can continue to pay miners the fees necessary to store that data and to keep storing new data that is added to the network for an extremely long time. Exactly how long that is depends on a number of different factors, including one that's very difficult to model, which is the price of AR in fiat terms. But there you have it, right? And given all of that, people are like, finally, like, oh, okay. One by one, there's like been a few nerds who've gone through kernel and other places like, and been like, wow, this is really cool. This is like a really wonderful place to go and like build something that's going to last at least 3 generations, more likely to be 30, and to think in very deep ways about what that means. So as I say, like, people have figured out how to bundle stuff on top of it. People figured out how to write smart contracts and atomic assets. Warp.cc is a good example of that. There was still though like some kind of usability concerns around Warp and like how exactly to price certain aspects of interactions with smart contracts. And again, I don't want to get too deep into the weeds there because it will come out a little bit in what we talk about with AR. But in the deployment of smart contracts on Warp and in working with these things, I think it became quite apparent to the guys at Forward Research and the other sort of core team people associated with Arweave that there was even more that you could do, and that if you sort of like liberated yourself from this kind of smart contract-esque mindset, you might begin to think in even deeper ways about what is possible when you have verifiable storage and the potential to build deterministic machines on top of that. And that's really what AO is, right? It says we can build a computer that has like verifiable and permanent storage, and based on that verifiable and permanent storage, we can do everything else that we need, right? So rather than trying to like go from the compute side and say like how can we all agree on the outputs of every computation at each step along the way, which is what happens in Bitcoin and Ethereum, right? Like Ethereum says like, here, like take a whole bunch of transactions, put them together into a block, have somebody like order the transactions in that block, and then like submit it to the network and say what the next like state root is, right? Compute the state transition functions, compute what the output of running all of those transactions is against the current state. And then we take that and we add a new block and we say, what is the output of all of these transactions against that new state? On and on and on and on. And always like, no. Let's do that kind of the opposite way around, basically. Instead of trying to agree upon the outputs of all of the computations, let's just assume that the logs, the messages produced by all of the computations are always available because we have this permanent verifiable storage thing going on. And if the messages produced by all of the computations, right, like if they're always verifiable and permanently there, and those are the inputs to our computations, then if we all running a deterministic machine, we can be sure that the outputs will always be the same, right? So if the inputs are always the same and they're always verifiably the same and permanently stored somewhere, then we can be sure that if we run them through a deterministic process, the outputs will always be the same. And this is like where you get, if you read their documentation, they'll talk about something called holographic state, which is kind of like a marketing term, but it's also enormously cool, right? I don't know how much you know about holographs, but like they're this like photographic medium that's essentially like allows you to look at things in 3D, but also like, and most importantly, if you break a holograph, each piece of the holographic medium will contain the whole image, right? So like in spiritual circles, people always like the soul is a holograph for the universe, right? Ooh, isn't that fun? That like this notion that like in you is a whole universe, that you're a holograph, right? And that's like what Arweave is saying with states. It's like, because we have this permanent verifiable storage thing going on, and like the messages of all the logs, nobody ever has like the outputted state at any given time, they have like a holographic version of it, right? Because you could always compute exactly what it is if you have all of the messages and you run it through your deterministic machine. But we don't actually like have to do that in lockstep, right? You know, why constrain ourselves in that way? We can constrain ourselves in other ways. Freedom being the awareness of the constraints that you put yourself under, and so that's kind of what they do. Now, I wonder if there's anything else that I want to say as context for this before we dive into the code. Yeah, if you've like read the threads, then you know that's running a process in Arweave, which is their version of a contract, is like just enormously easier than running a node in a like traditional blockchain network. You can run it on your local machine. You don't need some fancy hardware. You don't need cloud servers. You don't need any of this kind of stuff. You need node installed on your machine and like a terminal that you can open. That's basically it. And that speaks to this like ideological difference between like no universal consensus, don't enforce like lockstep participation of people and allow them to run stuff on their own machines in their own ways, and be clever about like the way that that data is stored and the things that you can do once it is verifiably and permanently a part of the record. So I think that's, with all of that said, let's like look at some fun code, I suppose, and hopefully that will illustrate a little bit of what I've said. If you need help with any of the memes in the presentation, please feel free to ask. But let's take a look at some code, because I think that that's probably going to be most illustrative of some of what I've talked about now. V, are there any questions, anything before I should just...
I mean, maybe a couple quick ones. The first one from Juan on if AO is superseding Warp and SmartWeave, the previous contract systems. Maybe we get into that. Is the answer?
Basically, yes. Yeah, and that's it's like another whole like thread of the story, I suppose. That's yeah. You know, I think that it's much more powerful and it's much more general. I think there are some people that are maybe like a little bit upset about that in the Arweave community. I'm not like too close to it, so I don't really want to comment like too much. I know that there was like some back and forth, and that some of the older contributors are like a little bit upset about the way in which it is all played out. And you know, that's like part of the course. As networks become more valuable, more useful, there's inevitably more personal conflicts around them.
I think we have another one on proofs, but we can get back to it if that works with you.
Yeah, the proof stuff is really interesting. I want to like go through some of the code first, and then maybe we can come back to it, just because it tends to like go a little bit too far down the rabbit hole, and I want to try and like have us like run some stuff, because that's the whole point, right? Like, is that you can like you can play with this thing yourself and get a felt sense for it, as opposed to just listening to me like spout off like random like intellectual ideas. So let's share screen. And we will take a look first over here. You can see that I was updating Zoom. Thank you, Zoom. So the first thing that I would like you to do is just run AOS. If you haven't installed, and I did ask for everybody to get it installed before coming to the call, and you can find I think, what is it? It's a cookbook, right? There you go, cookbook. If you need it, here's the install command. Just for those who are joining the stream, basically, you need node install, and then it's just npm install it globally, and that will get you AOS. Once that's happened, you can type AOS in your terminal, and you should see something like this appear. Right, you're now part of the hyperparallel computer. It means like a little bit. It already feels different, right? I don't know if anybody has ever run Geth or one of these kinds of things. It doesn't look like this, right? There's a whole bunch of stuff that happens in peer connections and e-nodes and oh my god, and London and Denkun and Istanbul. It's just like a whole bunch of stuff. Here you just have some cool terminal art and process ID, which is kind of interesting, right? And it tells you, the first thing that it says here is that you can load blueprints, and that's kind of curious too. This seems sort of fun, I think. So I think that the first thing that I would like everybody to do, if you haven't already, is just load the chat blueprint and see what happens. This is somewhat interesting. And once you do, you will see that it connects you to something called dev chat, and we can communicate. It's already feeling a little bit like IRC, if anybody's ever used that. And I can do a whole bunch of different things, which is kind of fun. And all of this looks like IRC except for the tip part, which seems new and interesting. And if I do what it says and I list the rooms, then I'll see kind of what's going on. It's getting a room list from the dev chat index. And there we go. We've got random quests and getting started. So that's great. I feel like we're getting started here. So why don't we join getting started. And I just happen to know that you can also pass in your nickname when you join the chat. So if you join the getting started, you can add your nickname, and that's what should sort of, there we go, I'm registered. And now if I continue following the commands that it's put into my terminal here, I can send messages to this chat, which is great. And I want to say, let's see, say, hello Colonel, and I want to pass that to the getting started room. I won't have to type getting started every time. It should remember what I want to say and in which room I was last talking. But there you go, I've broadcast a message to the getting started. And that's kind of nice. There we go. So we've got already someone, let's pop in. I like that one, that's a fun nickname. And there should be, I mean, you can send whatever message you want, and you should see some other people pop in and out of here as you go along and start chatting. So like it's very curious if we just take a step back that okay, we've been talking about quite deep sort of permanent storage, verifiability, consensus algorithms, no universal consensus, karma, how people play different games. In the presentation, I even kind of say there is but one infinite game, which is the final line of Finite and Infinite Games by James P. Cass, if you're wondering where that quote comes from. And this is kind of the point about, all of this stuff is that that sounded really complicated, I know, because I said it. But the first thing that we're doing is a chat room, and that's kind of curious, isn't it? It's well, it feels much more like a computer than Ethereum does, doesn't it? Right? Like when you first started using Ethereum or Bitcoin, I don't know if it really felt like a computer, right? It certainly felt interesting to me, and I was like, wow, this is curious, and I've not ever seen anything like it before. But when I first started using AO, I was like, well, I've seen this 100 times before. And it's just that the underlying architecture is quite different. And that's really exciting because it means, sorry, yeah.
Yeah, I'm also fascinated. I'm feeling the same things. I'm just curious, are other people seeing our messages and get started, or is this ours?
Other people who are connected to get started are seeing our messages now. I will. One of the things that I hope to do is to show you the chat room code for this and to introduce it to a different chat room that I made for a cool kind of meme coin that I made the other day because I've gone full degen because AO got me so excited. But no, anybody who's connected to getting started will be seeing this, be like, who the hell is going on? What are you people doing? But that's the point. Very funny. Hyper parallel global computer, right? So you see some weird stuff. It's the same as the internet, right? Like you're just hanging out, and all of a sudden, weird racist meme coins. Who knows? You never know what you're gonna get when you open your screen. So anyway, here we go. It's, as I say, it's just worth noticing that this is the first thing, right? Like, wow, it's quite curious. It's not like, oh, here's some weird Solidity code for an ERC20 token, and also be really careful about re-entrancy and XYZ footguns that you need to take into account as you consider how you might use this universal computer. It's load of blueprints and start talking with other people. And I really think that that's like worth reflecting on a lot outside of the technical complexity that we can get into in presentations like this. If you're curious about like what other blueprints exist, there is, like the terminal, the command line interface that we're using at the moment, this terminal application is like open source code, and it's all documented here in permaweb/aos, which I'll put in chat. And the other blueprints that you can load in your terminal include all of these, right? So the chat in the chat room is what we're using at the moment. ARNS is like the Arweave name service. Arena is a game that you can play against like other bots, and indeed, if you go through the tutorials in that cookbook that we linked to earlier, you will like learn how to write a bot. And that again, like it's very interesting, right? That's one of the first things that they take you through doing is like using the chat to interact with other autonomous agents and then build your own autonomous agents. And that's fascinating, right? Because it speaks to quite a different mindset from like, oh, here, build a token and then off you go. There are also like tokens, staking and voting, but that comes kind of later on. And it's, again, indicative of the mindset of the people that have built this and the kinds of uses to which it probably will be put in the long term, considering again that long term with Arweave is a very specific thing, right? Like people talk about like, oh, like long term when you hear like smart contracts, it's there forever on Ethereum, whatever. But forever is kind of this diffuse and rather abstract notion, right? Nobody actually knows what forever means in the context of Ethereum or Solana or Avalanche or any of these chains, right? Like, yeah, it's probably going to be around for a while, but like in forever. Whereas like Arweave is very, very specific about it, right? It's price estimates based on storage for the next 200 years, and then this endowment with a very, very, very detailed economic model about what that might mean for how long it could be stored, and then historical examples of previous archives that have been rolled up into Arweave itself to illustrate the way in which storage, as it improves and as the cost to do so decreases, always subsumes that which has come before. And this is a trend which exists long before digital technology, if you look at like papyrus and then books and so on, right? So yeah, I think that that's quite exciting, and it forces, it puts the mind in a quite a different state when you think about like this term like permanence or forever, right? Because somewhere in kernel, I remember writing this, and it's not really something that we've ever discussed much before. I said like permanence is the trivial idea in a world premised on transience, right? I think it's somewhere in the gaming, if you want to go and look for it. But permanence is the trivial idea in a world premised on transience, right? If you go and like really like consider who you are and do like a lot of the inner work that we don't ever really talk about in kernel, but which is just implied by the nature of the syllabus, then you understand anicca, right? Like all things are impermanent. So like what does that mean in the context of working on so-called permanent technologies, right? And it's a very, very interesting thing to consider in your own umwelt, in your own life, right? Like if you're working on so-called permanent technologies and you deeply embody some of the ideals about anicca or impermanence, or as it's taught in like kind of every tradition in different ways, right? Then like what does it mean to confront the context in which things are constantly sold as permanent? It's fascinating. And I would say that Arweave is probably the most honest of all of these, because their notion of permanence is very specifically defined. And it leads to all of these interesting things, like universal consensus, different approaches, and the ultimate outcome of this is, well, the first thing that we do is like chat, which is kind of nice. There we go. So lots of interesting stuff there. Now, I took a look at all of this and I was like, this is wonderful. I love this. This makes sense to me. I love the fact that the first thing is a chat. It feels like a world computer in a way which nothing else has up until now. But I've spent the last 10 years of my life specializing in like tokens and voting and staking. So that's the stuff that I know. Like I'm gonna go and like build some stuff around it, right? And if you take a look at like the token blueprints, you'll see for the first time in this presentation, what the language that we're working in here is called Lua, L-U-A, and it's really quite easy to learn. And I say that with some hesitation because I know that like if you're not a programmer, then like no language is necessarily easy to learn. But even as a non-programmer, it's really quite straightforward. It's used in a lot of games, and it's as easy, if not easier, to write than JavaScript. The only reason that JavaScript is not used here is that it's not deterministic, right? And we need a deterministic language because what we're doing is agreeing on the verifiable permanent order of inputs to computations, not on their outputs. The outputs of this holographic state thing. And you can, if you've like seen JavaScript before or anything like it, you can kind of grasp what is happening here with Lua. I suppose like in the same way you sort of like declare some imports, like library files that you need to help you do certain things here. And the thing that I most want to sort of focus on is that like each thing that you add to your process is added through handlers, right? So if I go into this current process, I can write handlers.list, right? If you've joined our chat. And every function that I have added to this process that is running on my local machine is listed here, right? You can see that these two default handlers, the evaluation one and just the default one, and then a whole bunch of different stuff that I added with, when I was testing this a little bit earlier with cred, which is like a test token that gets given for completing quests on AO. And then these two handlers are what we just added when we said load blueprints chat. We added the dev chat broadcasted handle and the dev chat list handle. And every time that we want to add new stuff to our process, which like the process itself is stored on Arweave, right? So like I can like add something to this process in my terminal, close this process here, right? And that process is always available and people can send messages to it because it's stored permanently on Arweave, right? And that to me is like really like the mind-blowing part, right? Because like if I'm running Geth, I always have to make sure that I'm running Geth in order for it to be responsive. This is not the case with AO, right? Like you start the process on your machine, you code whatever you want onto it. That code is like sent in a message, right? And this process itself is a transaction ID on Arweave. And if you go and look at that transaction ID, then you'll see that there's like a module which is compiled WASM, and like that's what responds to any messages sent to that process in perpetuity, right?
So can you
in perpetuity is
yeah, I know how I can sense how huge it is for you, but can you further illustrate like what was the paradigm prior? If this was Geth, for example, like you have to, because at least in my head, what comes to mind is like it reminds me of like a smart contract to some degree, but that's where I feel like I'm missing something.
Okay, if I run Geth, right, this is what it looks like. There's like a whole bunch of stuff that happens. Here's like all of the hard forks. Here's like the eNode thing that I was talking about, my P2P networking. There's like a whole bunch of things going on, right? And this is just like a dev version of Geth. It's not even like Geth, right? Now, if I like wanted to interact with it, I could, right? Let's see, this is really me now on the fly to try and answer this question. I wonder if I have any kind of... so here is like some stuff that's going on. Let's say if I want to interact with that version of Geth which is running, I can like take a smart contract, right? This is like an example of a smart contract. If you've read Solidity, this is kind of like what we were doing in a previous presentation on Suave. I can like build it, and then I can say, just get the syntax right here. I can like deploy that, right? And there it is, like that the contract got built and it deployed fine, and I get like the address and everything, yeah? But if, and this is the contract, right? Oh my God. There it is. And it's all deployed, right? But now if I stop geth, right? And I go back and I try that same command, right? Connection refused, right? So this like the geth has to be running. It has to be like appear there to like send stuff to him, be like, hey, hello geth, like please will you tell me what the result of me sending you this thing is, because like we all need to like remain in consensus about what's getting out of the network, right? And there, so like that's how geth works. But with AO, like here, like I've got all of these handlers that I've added. This is the process ID, right? Like the process ID is there. This you can go and find on our weave, right? And if you like go and look, there is a WASM module that is the data of this process ID on our weave, right? And that WASM module is kind of like a 4 GB RAM VM, right? That's like the VM is rolled up into that data on our weave. And every time I add a new function to this, whenever I code something or whenever I add like from the blueprints or whatever, that's like a message that gets sent to this process, and it says like, hey, add this function, so that you can like respond whenever anybody sends you a message. And then whenever anybody sends a message and the recipient is this process ID, it will like execute stuff in that virtual machine and like return a result, right? It's kind of amazing, to be honest. I don't know how else to describe it, and I'm sure that I'm not doing it full justice, because you know, there's probably like more technical ways in which I'm just really trying to like give the felt sense of this thing, as opposed to kind of working with some of the existing technologies, and just how different. But they call it the storage compute paradigm, right? Rather than Byzantine fault tolerant systems. So BFT systems are like a whole class of thing. There's a huge amount of academic literature. How do you like solve this problem? And like, we've been like, okay, like, yeah, but we're not Byzantine generals anymore, right? Like, what else could we do from a life? What other results from a life wholly lived, right? Well, like, this is one thing, the storage compute paradigm, everything, like, the storage is verifiable and permanent, and we can do interesting things in that storage, like a WASM VM. But, you know, the result is this kind of, it's quite simple in the end, although perhaps that hides a lot of the like really amazing stuff that is being built under the hood here. So yeah, there you go. We're not going to be able to get to everything that I had planned for today, but what I sort of wanted to just touch base on very, very briefly was that if you go and take a look at like well, first of all, just to explain these handlers, every time you want to add something to your process, you can say like handlers.add. There's a few different ways of doing it, and if you read through the documentation, you will become conversant in these. You can do like handlers.prepend or handlers.postpend, like a bunch of different things, but it expects always, like each handler expects 3 what we call arguments, right? A name for this handler, so in this case, like we're calling our handler info or balance, and then 2 functions, right? The first function often, although not always, and you will see some code where this is like very different because it's general and it's very flexible and it's very simple. And the simplicity is its genius, right? But generally speaking, the pattern for handlers is to give them a name and then say like what tag they're listening for, right? So they're saying like, when you, my process, receive a message that has a matching tag called info, then run this function, right? That's what this code is saying. It's saying like your name is info. When you receive a message that has an action tag called info, run this function, right? And that's like the basic structure of pretty much everything that you will see in this presentation for sure. And like most of the stuff that you'll see built on AO at the moment, although it can get more advanced. And what it's saying, the function here is very, very basic. It's just saying send a message back to the person who sent you the message and tell them what the name of this process is, what the ticker of the token is, what the logo is, and the denomination of the token. So just give them the information for the token, right? So like they've sent you a message, it has the tag info, so they're clearly looking for information, send them all the information you have about the token, which in this case is the ticker, the logo, the denomination, and the name, right? The same thing for like the balance. It says like your name is balance, you're looking for any message that has an action tag called balance. We run this function which like does a little bit more computes just to make sure that you like do have a balance, and then it sends you what your balance is along with the ticker and this kind of stuff, right? And you can find that pattern repeated over and over again in slightly more complex ways for instance, transfer and so on. Mint is further down. Yeah. Now there's also like staking and voting. And I was kind of hoping to like give a little bit more detail about these because like I took offense as a governance researcher and somebody who's like done a lot of this kind of work and written a lot of code in this direction. I was like, you know, I worked on stuff at Maker where we did like incredibly cool, you know, ranked choice voting, and DS Chief is a marvel of governance art that few people properly appreciate, and blah, blah, blah. So I was offended by the staking and voting blueprints, as you know, wonderful as the person who is that wrote them, and really he is a truly wonderful human being. So what I did, if I can just, sorry, that's is I went and built a different way of staking and voting because, you know, like why not? And that way of staking and voting is over here. Let me just find it. You can see that person actively helping me be offended about his code. So props to him. Essentially like what I did, and I don't really have the time to get like too deep into it because I want to show you like one more thing about like how to actually interact with these processes is I did away with a lot of the complexity in having like staking and voting blueprints, and instead just said like if you know, like you don't if you read through the staking and voting blueprints, you first have to stake and then you can vote in any direction that you want, and you can vote as many times as you want and all sorts of stuff. And I kind of disagree with that way of doing things. I think that like if you're going to vote, it should be like meaningful. You should put your money where your political voice is. And so in this case, when you like stake, you stake and vote at the same time, and your tokens are given to that process, right? They're not sort of like escrowed in a separate process anyway. Like you move your tokens in order to vote, and this is based on a lot of my own work. If you go and like look at dApps or some of the previous systems that I've built, that's like this is all of the thinking behind dApps and a lot of like the early work that I did in Ethereum in, what is it? It's I think, yeah, 190 lines of code. It used to take a lot more in Ethereum these days, like because Lua is much more general and I can do like all sorts of interesting stuff. And like what's happening here is I'm saying like initiate a table called proposals. And then I can like do whatever I want to that table. I can like add information to it. I can remove stuff from it. I can do all sorts of fun things, and I can give it any structure that I like. And you can actually see that proposals has like quite a lot of information in it, right? You can't do that in Solidity. Try and work with arrays in Solidity. It's a recipe for madness. If anybody has, then you know what I'm talking about, right? And like, again, while it might not be as apparent to those who haven't programmed before, the feeling of this is just radically different, right? Just as like the first thing being a chat room as opposed to like some weird tutorial on a token, like again here, when I don't have to worry about like, oh, I can only work with fixed length arrays, or like there's some crazy footgun about like the order in which I write my lines of code such that like if I put the wrong line in the wrong place, I'm gonna like lose $100 million, whatever. Like here it's very different, right? And I took issue with the staking and voting blueprints, and I built in 190 lines of code something like quite different that works on some quite different political science assumptions. And then you can build like a very simple front end for that in kind of no time at all. And that's sort of fun. The way that you build the front end is with something called AO Connect, which I don't have time to demo today. But you can see an entire like voting application here. And if I just, I suppose, let me take a look very quickly at what this code looks like, because you can see how sort of like dead simple it is. It's literally just like a one-page Next TypeScript app that imports AO Connect over here, and then like does a bunch of different stuff. And like this was a little bit more hacky because I thought, well, why not just put it all on a single page? But again, like the point is that you can like make like a really quite advanced like political science statement in, I don't know, this is a bit more, this is 500 lines of code for an entire front end that implements like this permanent process, which is written in 190 lines of code. And that's quite exciting. So I know that we're sort of at the top of the hour and that I need to stop, but there's one last thing that I would like to show you, just because like it's worth kind of seeing. They had a competition on Arweave to kind of like see if you could build meme frames, which is this concept that you could have a website with an iframe, the content of which is defined by a community of token holders, right? And they wanted to use the vaulting and staking blueprints. So I was like, before the contest, I was like, let me show you how to do it better. And everybody was like, okay, that's cool, but also like we need to have this contest, and like this is the vaulting and staking blueprint. So I built another website that uses those vaulting and staking blueprints and inserts any given transaction ID into the iframe, and then allows anybody to vote for, whatever they want to see in this iframe. So at the moment, you can see that it's a frame from Finding the Blue Book, which is kind of fun. That's what has been voted for at the moment. But I wanted to kind of illustrate like voting for something else. At the moment, you can see that there are no votes. And if I just show you very, very briefly what is happening here, you can see that I've also like written just a little bit about like the meme frame. It's mostly about like how to use it, and then like a little bit of code that I added. And here you can see instead of like handlers.add, I'm using handlers.prepend, but it's like exactly the same three. You give it a name, you give it like some function that is its initializing condition, and then some function that will run when that condition is met. And what I want to do here, because it's all set up, is I would like to send a vote for a different thing and see if it appears in my website. And now this is a little bit of a story. So here we are in AOS. We've got a whole bunch of different messages from like a whole bunch of different people going on there. But I'm going to try and send a vote for a particular transaction ID. And if you take a look at this transaction ID, then you'll understand why it's called memeception. I hope, there we go. I've successfully voted. So if I go back to my website, that's all like happening in the terminal on AO and Arweave. If we refresh here, and because Zoom kicked me earlier, there we go. A vote has appeared. And if I go and like check, what am I voting for here? Oh my gosh. It's the original thing with like a different staking and voting thing behind it. Isn't that funny? Memeception. So there you go. You can do kind of like anything you like with this sort of thing. As general as, I don't know why it's asking me for so many different things. But there you go. You have a whole bunch of stuff, and I can vote yes or no. I'm going to vote yes, definitely. That's great. My vote is successful. So in like at this block height on Arweave, you will see if you come back to what-meme.arweave.dev, you will see that the homepage will no longer be chapter 8 of Finding the Blue Book. It'll be memeception, which is hilarious. And if you wouldn't like it to be that, the last thing that I will do is I will add in a different vote. Why not? And this was one of the reasons that I didn't really like the staking and voting blueprint, because like once I've staked with this account, I can vote as many times as I want. And I was like, it doesn't really make like political science sense to me. Like if I use my tokens to vote, I should use them. That's the whole point of having these systems where you can like, have as many tokens as you like, and scarcity is an aesthetic choice. It's not like a principle of nature. Anyway, so I've now voted for that. So if you if you go through the rabbit hole and figure out how to get a hold of some meme, then you too can come and vote, and you can see that there's 2 votes now. One is for Memeception, the other is for chapter 13. Chapter 13 is, I know Fang's favorite chapter, I think. So it's lovely to have you on the call, Fang. Anyway, I'm so sorry for taking the whole hour. Please, if there are questions, I'll stick around to answer them. But there was a lot to get through there, and I really thank you for bearing with me and for giving me the space to go through it all, because I find this stuff pretty exciting.
Thank you.
So I put a quick quote in there from Sam, where he was basically said that you get rid of every other interaction type with an AO parallel computer. It's just message logs, and the whole system is like a massive event queue. And so the idea, I think, is that like right now, if you're trying to build an agent using a smart contract, it's very difficult to come up with this messaging interaction between all of these different processes, right? And so I think that by building it this way, that you're able to, take advantage of that and be able to talk to these processes pretty easy. Does that make any sense, Andy, or is that?
Yeah, exactly. Exactly. Yeah. Yeah. Messaging queues are like very powerful abstractions, right? And like the Ethereum line of technological development has followed quite a different trajectory. And that's wonderful. Like we're all here because of it. But there are alternatives, and it's very interesting to know about them. It's very interesting to play with them and experiment with them and kind of see where they go. It's been interesting to watch the increase in activity on AO as a result of this message passing model, just because it's so much more intuitive, and it maps more closely onto kind of our reality, right? Like if you think about like how like implicitly we rank each other as social peers, right? We might not like to acknowledge that, but we do. And I think that there are ways in which we can do that like in a much more healthy and coherent and like conscious way, and that's like a big part of the journey, right? But when you think about it, like nobody is ever explicit about like how you rank other people in your social environment, right? You're barely even explicit with yourself about it. In fact, like it's a huge jump to be able to have like the self-awareness to be like, oh, this is how I am thinking about that other person because of X, Y, and Z. And it's the same way in AOE, right? Like you don't, that same features that you don't have to be explicit about how things are ranked. You don't have to, and yeah, the same thing applies to message passing, right? Like messages are how we communicate. They're naturally how you enter into dialogue. It's through dialogue that you understand anything in the world. It's through dialogue that powerful relationships and connections are formed. And so like a message queue makes sense for like complex interactions of various different kinds, which are built out of these very simple conversational primitives, right? You can go all the way back. I know that you probably know of this and might even have like done some work around it, but like if you go back to the work of Pask and Pangaro, right? Like conversational theory, and that whole branch of British cybernetics is about this, right? Like conversation theory is wonderful. I'm still trying to find a way to put it into the conversation part of the kernel. So it's somewhere in there, I think. But like, it's beautiful. And it's like, if you go and read that stuff now about conversation theory, and then apply it to message queues and AO, like it's unbelievable. I'll put a link in the chat if I can find it in time. But yeah, great
And you
points.
could say that that's why, when ChatGPT came out, that's why it was like such a huge thing, because people were able to converse with the computer just in regular, at the conversation level, basically. And, and the way you can do that even with this AO now with the chat, which is really great. So, yeah.
With this thread and the talk about agents, I conceptually understand directionally like why this is the case, like why agents could talk to each other faster, why it would be more scalable given everything, all the context that's been shared. The part that I'm struggling to tie to, given my own limitations, is basically like in the blueprint level of like, is it that you would write a blueprint in Lua that represents an agent, and how an agent, like how much do you have to specify how an agent, would you like for example, like bring in, if you're talking about an AI agent, are you like in Lua coding in some tied to something like a GPT, and then agents are talking to each other? Like how is that actually happening?
let's just go one folder up here and take a look at the bots. So like this is a bot for that arena game, right? And it's one that I wrote. So you can take a look and basically like it again, like we initialize like some few tables. My computer is ailing a little bit, so might be slow. Anyway, can you hear me?
Yes.
Okay. Yeah, I'm not sure if this my computer might just crash. Hang on. Can I just
The
try
spider.
and close some things? Yeah. So I mean, like, okay, I was trying to show you like the bot code there. It's a Lua script that's probably 150 lines long, and basically like what I was doing in that script was trying to get my bot to decide on the next action, because the arena is this 40 by 40 grid, right? And there's like you're on like some grid, and then there's some rules about like how you pick up energy, and then your energy is how much damage you can deal in an attack, and you have to be next to another player to like attack them, right? And so like the code that I wrote was like decide next action step, and it's like saying if you're within 5 squares of somebody else and you have less than like 20 energy, then like run away, right? And like if you have more than like 50 energy, like move towards the nearest player and like attack them, right? That's basically like what the code is saying. And it's like 100 lines. And that is like an AI agent, right? But
Could you like in natural language say something slightly more complex to that bot and like call in, let's say like call in to a GPT or use the API to bring them into being able to make decisions on the fly type of thing?
yes. So there's 2 things to say to that. The first is that you can make significantly more complex agents just in Lua yourself. And the way that you like might imagine doing that is, pulling in any kind of news feed and then having an agent make trades on your behalf based on like that news. So can you still hear me?
Yes. Yes.
Yeah, just because everything else is frozen for me. So yeah, you could like that would require like a fair degree more complexity. But then we're talking about like machine learning models of the kind that like high frequency firms and these kinds of things run, which is fairly advanced, right? Or indeed you can do, there's a service on AO already called Orbit, which allows you to make any arbitrary get or post requests to like endpoints on the web. And so like if you wanted to like, post certain queries to ChatGPT, the completion endpoint or another, you could do so with things, both by leveraging existing
Yeah, we're losing him, right? Yeah.
Too close to the sun. We tried. I was enjoying hearing about those possibilities. I hope that question was meaningful to others. I'm really interested in doing more with AO personally. Trying to figure out maybe some Lua and it seems like everything that Andy's describing, one of the big things is just like some of these things would be cost prohibitive on Ethereum. Is that, Holly, how you understand it? That these
Yes. Yeah, definitely. And then the other is the messaging thing that I was saying.
Mhm.
So, if you try to, think about like, okay, I'm going to build this smart contract for agent A and then another one for B, and then how are we going to interact between these two smart contracts, right? It becomes very complex at that point to try to be able to do that. And so that's why, having this already built as the layer underneath this message queue, it's really great because then you can just kind of, throw things out and, interact that way. So that to me that's the unlock for me. Yeah.
So in that example, it's like if you have two Lua bots that both are basically, I think that is it processes that end up in the message queue, and they can on a self-directed basis talk to each other. However, is that the right way to think about it?
Yeah. Well, that's how I would. Yeah.
Okay. Yeah. We're talking about trying to run with what you had, Andy. See, you're frozen again. Can you hear us?
Oh, there you are. We see you now. Can you hear us, Andy?
Yes, sorry, my computer crashed. I finally got off the ghost.
We were talking about, we kind of ran through an example of like two bots, both written in Lua, both both processes, I suppose is the terminology, that then could talk to each other or pass messages to each other on the message bus. And that's where we got.
Yeah. Yeah. And so like in addition to making just more complex agents than what I was going to demo with that arena bot, you could, like scrape a news website and then build an agent that makes trades based on the news that it finds from a variety of different sources, right? And you can go further than that because there's like a service on AO already called Orbits, which allows you to make like arbitrary get and post requests to any HTTPS endpoints. So, you can actually like call GPT if you wanted and like receive a response and then take actions based on its response, or like do something more like Dhruv was doing, which is like use like LangChain and Hugging Face and like many more of the open source models, because like that's probably more fun. And the there's a whole like, I saw Juan asked if there's like stuff that you can only do on this, and that like you can verify TLS encryption certificates in your process, so you can be sure that the information that you're pulling from a web page is indeed the information that's on there verifiably without using like an external oracle or anything, which is like quite a powerful thing that is not really possible anywhere else. Or we just not really a blockchain, so I won't say on this blockchain, but yeah, you can do a bunch of stuff like that, leveraging other models in addition to writing like much more complex things than I've shown you. Like autonomous finance in that tweet that you shared from Tate's Barenbaum, have written like a DCA agent, right? Like a dollar cost averaging, which is like a lot more complex than anything that we looked at today. Yeah.
I could ask because when I think of Arweave, I think intellectually the places I go are like archives, user trails specifically, like that type of thing. Have you thought of unique use cases, let's say as it relates to like libraries or like moving through information? I think you're muted
You're on
now.
mute. Yeah.
Yeah, there's this dream of the library economy. It's a video posted somewhere in the kernel stack. And I think that a lot of the stuff like built into Arweave is pointed in that direction, right? So if you think about what we did with Sam, it was about profit sharing communities, profit sharing tokens. This was the notion that you could have like a perma web app And that's where like Warp was really going, right? Like you could build smart contracts, perma-web apps, and the smart contracts define a profit-sharing community who runs that application, right? And it defines the rules for how profit is shared, resulting from the use of it, which is somewhat in line with like what is being told in economies video, which is like way back in the kernel stack somewhere. Library economies being places where, you know, like resources are like essentially like where resources are really well allocated based on need, you know, that like when you know, like when you don't need tools or your bicycle, like you know, there's yeah, I don't want to kind of butcher what's in that video, and I watched it a few years ago, but it's well within the realm of the possible if you look at like the work of yeah, PSTs in particular. The question I have about this default first is like Sam is quite careful when he talks in public about the degree of value that can be guaranteed given the storage model and the way that Arweave works. This is somewhat linked to what you were asking him, Vivek, about information value density. And, you know, the underlying mechanics of Arweave, it's clear to me how much value can be truly securely stored in a given application, as opposed to, yeah, like given like the way in which like mining and underlying like network works. I haven't phrased that exactly well because I'm still not sure myself exactly how to approach the problem. And secondly, and this is the more difficult thing actually, is like it's just how much attention can they garner, right? It's like in order to build economies of really big scale, you need like a lot of attention. And I think almost, yeah, like I feel pretty confident that in the long term, like Arweave is really something that a lot of people will use. It's simple, it will last long, it's elegantly built, and it doesn't depend on any particular person or organization. Will it be the case in our life? You know, like I'm a little bit less certain of that. And yeah, so that's kind of interesting. Like, is it possible to bootstrap an economy without a whole bunch of people? It's that old chicken and egg problem. It's the same thing with Anna, right? It's like, okay, cool, you can like write a different kind of money, but you need like a different mindset in a lot of people in order to make that really meaningful. So yeah, that one's a little bit more difficult to like quantify and answer because like attention is this very interesting thing. All you need is attention, right? Right, Holly? Yeah. Liquidity follows attention.
Yeah, I shared another image there, Vivek, for the, yeah, do you see that where it's showing the Arweave square there and then showing the, you know, you're looking at decentralized compute, you're looking at, you know, we're moving away from AWS, we're moving away from Google Cloud into a way of being able to make use of everybody's compute across the world. And but then what to me is that messaging layer is the thing. I keep harping on that, but you know, that's what's allowing these processes to communicate. So, and then there's some other interesting stuff with the deterministic, you know, what Andy was talking about at the beginning, you know, so
Yeah.
just to make sure, because you have to make sure that if somebody else is running a process, you have to somehow make sure that that process was actually run, right? And so that's where this idea of determinism comes in, and placing the inputs on you know, not on chain, but you know, within the AO. Yeah.
In the inputs. Yeah.
I mean, yeah, I know we're far over now, so I guess, yeah, I'm trying to apply it to this idea of like a protocol for peer learning environments. Let's just use this as an example. It's a far-fetched one that I'm still just trying to think about it at its base layer myself. But one thing I've thought about recently is like there's all this information all over the internet, and there are all these signs that people leave that show that they are in fact like possibly meaningful participants on a specific topic. And like a lot of those signs are left, um, they're there. They're like trails. You can find them. You can find, like, Holly, I can go to your personal website. Andy, I can go to the sites that you've made. I can even go to like one, 140 character tweet, well timed in a very specific context. And like one example, looking at this image that Holly just shared, that I'm thinking about is like an agent that like goes around and picks up all of the people that would be good participants in a group that cares about Stewart brand, and then somehow like breaks those participants up into groups of 4 to 5, but tries its best to do it in this like open and permissionless way where they are also encouraged to pass messages. I mean, like, you guys kind of know where I'm getting at because I'm talking about kernel, but like at a different level. And the point I'm getting at is like the base level is the stored information, which is what I see in this image as Arweave. But then what brings a kernel block to life is the messages. And that's why I think intuitively, even though I get very little about AO, I think why intuitively I was so excited about it was definitely the message bus and the sensation that like this reminded me of the dialogue that happens in a kernel block that brings to life the stored information. And and so like when I think of like even like the library economy idea and the more interesting apps that can be built on AO, my mind is maybe a one-track mind towards these like peer learning, like micro library environments that do pass information back to the storage layer that otherwise wouldn't get passed back because they wouldn't be created, because it's through the dialogue that they're created, if that makes sense. It's like, to me, I guess how it ties is like these like user-owned foundation models that people talking about in AI, I find quite fascinating because I think it's completely like, it's very simply correct that yeah, GPTs are cool. They're based on like scraped information off of the internet. Scraped information off the internet is obviously very important, but it's probably 1% of the corpus of information that could be created through dialogue and is being created on a consistent basis through dialogue day to day. Like, of course, the information has already done so much just by scraping, right? We see what GPT can do, but scraping is like, it's kind of like a violent and boring approach to creating like a really strong model, because a strong model would be based on messages. It would be based on dialogue.
Yeah. I think that's it's a way to go, right? I think that's like, as I say, the analogy of like these things are like more naturally intuitive in terms of like not having a like explicit protocol enforced like ranking model enshrined in consensus, and like it being basically a massive message queue. They're analogous to the kinds of things that can then be built on top of them. But the way in which they influence what exactly does get built, or what's natural to build, and what like garners the most attention is not like exactly one to one. So like peer learning communities taking place through dialogue in a place like this, sure, and I think that like the kind of dialogue is what's interesting to me, right? Like that's why the blueprints are sort of interesting in the sense that like you can share code very easily, right? And that shared code has an immediate effect in fascinating ways, right? And so like that is a kind of dialogue outside of like like agents passing messages to one another that arises from the architecture of the thing, which is fascinating. So like the chat room that I built is like a fork of Sam's with like a slightly different token getting. The what meme token is a fork. Well, it's a total rewrite of like their staking and voting, but it's still a response to it, right? It's a conversation. It's a conversation that is taking place between me and Tom, because like I happen to think that like politically, like in terms of political science, the ideas expressed in the voting and staking Lua files are fairly naive. But like that's kind of a crazy thing to say. Even the people in the like AO discourse are like, how can you call like a piece of code politically naive? But it is, right? It is fascinating. So like, yeah, the conversation, I don't know, it's you know, it is enabled, but what it exactly is and looks like and the level at which it takes place is always like worth being aware of and thinking quite deeply about. This thing is true, even on Ethereum. But like what this allows for, and as a result of the permanent storage, the archival kind of aspect of the thing, library economy, is that it means that you can have conversations even when the person is like absent, right? It doesn't have to be running a node. Like the process is there. It expresses an idea irrespective of like some important notion of presence. And that's fascinating, right? Because we like often, in fact, like I would say perhaps like the majority of conversations we have are with people in their absence. How many times have you rehearsed what you're going to say to somebody, and then when you actually finally like do meet them or whatever, like it comes out totally different. That's fascinating. Anyways, I don't know, but that's just riffing.
It's fun. Yeah, I appreciate the riff and everything. Really great session contributions from everyone who's here, and it's cool to see the chat message from Pauline gave me some inspiration when I got going. Great questions from everybody. Had fun. Thank you. All right, on. Take care. Take care. Take care. Take care. Bye-bye.